In this video, I solve binomial recursion formula. It has two parts. One is probability of capital X is equal to small x plus 1 is equal to n minus x over x plus 1 p over q. P is the probability of success, q is the probability of failure, and multiply with probability of capital X is equal to small x. And second part, probability of capital X is equal to small x. It is equal to n minus x plus 1 over x p over q. Probability of capital X is equal to small x minus 1. So here is the proof. The probability mass function for the binomial distribution is probability of capital X is equal to small x is equal to ncx p of x q power n minus x. This is the equation A. Probability of capital X is equal to small x plus 1 nc x plus 1 p of x plus 1 q of n minus x minus 1. This is equation B. So we divide equation B by equation A. Probability of capital X is equal to x plus 1 over p of x is equal to nc x plus 1 p of x dot p q of n minus x q of minus 1. We split these two terms. P is the probability of success. We write it as p of x p of 1 and q of n minus x q of minus 1 over ncx p of x q power n minus x. We cut these two terms because there is similarity between p of x and p of x. Cut this p of x and q of n minus x, cut with q of n minus x. We left with p q of 1 over q or q inverse, and we expand here combination formula. So when we expand combination, we write it as n factorial over x plus 1 factorial and difference of these two terms factorial n minus x minus 1 factorial. Similarly, we write it as n factorial x factorial n minus x factorial. Cut this term with this term, and we can write it when 1 over invert its position, we write it as x factorial n minus x factorial over x plus 1 factorial n minus x minus 1 factorial p over q. Because here 1 over x factorial n minus x factorial, when we take this number on the upper side, we revert this number and it becomes according to this equation. So now we expand x factorial n minus x minus 1 factorial. We expand the factorial. As you know, when you have 3 factorial, we write it as 3 multiplied by 2. If you stop to the number of 2, we write it as 3 multiplied by 2 factorial. So according to this, we decrease by one number n minus x factorial. We write it as n minus x into n minus x minus 1 factorial over x plus 1 in and decrease x factorial n minus x minus 1 factorial. Cut this with and this with this. We left here n minus x over x plus 1 p by q. Probability of capital X is equal to small x. So n minus x over x plus 1 p over x, probability of capital X is equal to small x. Hence we proved part 1. Now we start to prove part B. So first assume the probability mass function of the binomial distribution, which is ncx px q power n minus x, and probability of capital X is equal to small x minus 1 nc x minus 1 p power x minus 1 q power n minus x plus 1, dividing equation C by equation D. So probability of capital X is equal to small x divided by probability of capital X is equal to x minus 1, and here nc x p power x q power n minus x divided by nc x minus 1. We split this number, write it as p x p minus 1 q n minus x q 1. Cut these terms and expand the factorial n factorial over x factorial n minus x factorial. Here n factorial x minus 1 factorial n minus x plus 1 factorial. So we left with p over q, q over p we write it as p over q x minus 1 factorial n minus x plus 1 factorial over x factorial n minus x factorial. So again elaborate this. N minus x plus 1 we write it as n minus x factorial. Cut this term with this term and x minus 1 factorial with this. And we left with n minus x plus 1 over x p of x. So we write probability of capital X is equal to small x n minus x plus 1 over x p by q. Probability of capital X is equal to x minus 1. Multiplying these sides by cross multiplication we have this, hence we proved. I again look this point x minus 1 factorial. So here we decrease by one term. When you expand factorial x into x minus 1 factorial, because we want to stop this, we cancel out with this number. So similarly we have n minus x factorial. We cancel out here in this equation, we need this number. So we also expand this factorial n minus x plus 1 and decrease by one number n minus x factorial. So cancel out and we have this number, multiplied this term on the right side. So we prove the second part, which is probability of capital X is equal to small x is equal to n minus x plus 1 divided by x p over q. Probability of capital X is equal to x minus 1. This is my channel Statisticians Club. Please subscribe this channel and you can find solved proof of all discrete and continuous distributions on my channel. I already solved discrete, uniform distribution, Bernoulli distribution and binomial distribution. And within 1 month I also solved the remaining distributions. Keep watching Statisticians Club. Thanks for watching.